Hi class. So our topic for today is all about finding the common factors and the greatest common factor of 2 to 4 numbers using continuous division method. So let us first have a short drill. Identify whether the given number is a prime or composite. If it is a prime, you're going to say hep hep, and if it is a composite, just say hooray. Let's get started. The first one is 12. Is it a hep hep or hooray? Yes, it is a hooray. How about 7? This is hep hep. How about 19? Yes, it is hep hep. How about 46? This is a hooray. Hooray because it is a composite. How about this one? 79. 79 is hep hep. And we have the last one, 54. What is it? Yes, it is a hooray. So now, let us have a short review about factors. Tell whether the number is a factor of a given number. Say yes if it is and no if it is not. Where we have here 54 factor 6. Is it a yes or no? The correct answer is yes. How about 14 factor 3? Is it a yes or no? Correct answer is no. Very good. How about 27 factor 3? Yes or no? The correct answer is yes. Very good. How about this one? 105 factor 10. Yes or no? The correct answer is no. The last one we have 24 factor 12. Is it a yes or no? Correct answer is yes. So let us explore more. I have here a problem, and we are going to solve this problem by finding the greatest common factor of the given numbers. Are you ready? So here is the problem. Jenny has 24 red flowers and 36 yellow flowers. She wants to make bouquets with the same number of each color flower in each bouquet. What is the greatest number of bouquets she can make? So here we are going to find the greatest common factor of 24 and 36 so we can able to find the greatest number of bouquets that Jenny can make. We are going to use the continuous division method in finding the greatest common factor of the given numbers. So let us first define the meaning of greatest common factor. When you say greatest common factor, this refers to the greatest number that is a factor of 2 or more other numbers. When we find all the factors of 2 or more numbers and some factors are the same, then the largest of those common factors is the greatest common factor. So, now we are able to define the greatest common factor. But what do we mean when we say continuous division? When we say continuous division method, this is also known as ladder method. This is a process of solving for the greatest common factor of a set of numbers. It is done by repetitive division with common factors as divisors and multiplying all common divisors to get the greatest common factor. In order to get the greatest common factor of the given numbers, using the continuous division method, we are going to follow the following steps. So the first step is place the numbers inside an upside down division bar. So we are going to place the given numbers inside the upside down division bar. We're going to put 24 and 36 inside this upside down division bar. 2. Divide both numbers by a common factor. Since these are even numbers, we can start with 2. Then 24 divided by 2 is 12. 36 divided by 2 is 18. For the step 3, continue to divide until we have two numbers that are relatively prime. When you say relatively prime, the given numbers do not have the common factors other than 1. So we have here 12 and 18. 12 and 18 are both divisible by 2. So we have here 12 divided by 2 is 6. 18 divided by 2 is 9. 6 divided by 3 is 2. And 9 divided by 3 is 3. So we have now the numbers that are relatively prime. 2 and 3 do not have the common factors other than 1. For the step 4, take all of the factors on the side and multiply them together. So 2, 2 and 3, we're going to take them all and multiply them all together. We have 2 times 2 times 3. 2 times 2 equals 4. 4 times 3 equals 12. So we have here our greatest common factor is 12. Going back to the problem, we found out that Jenny can make 12 bouquets since 12 is the greatest common factor of 24 and 36. She can make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bouquets. And each bouquet has 2 red flowers because 24 divided by 12 is 2. And each bouquet has 3 yellow flowers since 36 divided by 12 is 3. Let us have another example. So let us put all the numbers inside the upside down division bar. We have 28, 32, and 40. So 28, 32, and 40 are divisible by 2. 28 divided by 2 is 14. 32 divided by 2 is 16. 40 divided by 2 is 20. So 14, 16, and 20, we're going to divide again this by 2. 14 divided by 2 is 7. 16 divided by 2 is 8. 20 divided by 2 is 10. Now, we have here 7, 8, and 10. 7, 8, and 10 are relatively prime numbers. They do not have the common factors other than 1. So we're going to take 2 and another 2 and multiply them all together. 2 times 2 is 4. So our greatest common factor is 4. Another example, we have 42, 56, 70, and 98. Let us divide them by 2. 42 divided by 2 is 21. 56 divided by 2 is 28. 70 divided by 2 is 35. And 98 divided by 2 is 49. 21, 28, 35, and 49 are both divisible by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. 35 divided by 7 is 5. And 49 divided by 7 is 7. Now, 3, 4, 5, and 7 are relatively prime numbers. So we are going to take 2 and 7. 2 times 7 is 14. So our greatest common factor is 14. So let us have another word problem. A music teacher and a physical education teacher combine their first period classes for a group activity. The music teacher class has 24 students and the PE class has 16 students. The students need to divide themselves into groups of the same size. Each group must have the same number of music students. So we are going to find the greatest number of groups possible. So we are going to put 24 and 16 inside the upside down division bar. So we have here 24 and 16. So 24 and 16 are both divisible by 2. So 24 divided by 2 is 12 and 16 divided by 2 is 8. 12 and 8 are both divisible by 4. So we're going to divide 12 divided by 4 is 3 and 8 divided by 4 is 2. So now 3 and 2 are relatively prime numbers. So we're going to take 2 and 4 and multiply them all together. 2 times 4 or 4 times 2 is 8. So our greatest common factor is 8. 8 is the greatest number of groups that is possible. Thank you for listening.